No. Hello.
Oh yeah, working. Yeah. Yeah, okay. Good morning, everyone, and welcome back. So today, what I would like to discuss more is more on the gas, the syngas, the syngas hydrogen energies from biomass and from other renewable sources. So before I continue with the syngas, I would like to make a little bit more about the life cycle cost analysis, right? Because yesterday is two rushings. So I would take maybe a few minutes to discuss about the life cycle analysis and also the environmental, economical, and social economic impacts on the certain biofuel plants productions. So yeah, before we proceed with the life cycle cost analysis and models, so if you have the certain technologies already proven it's working, so you have the data input, to do the accurate cost analysis as well as the environmental impact analysis, which normally we call it the life cycle assessments. So yesterday, some of you asking me, so what is the suitable software to analyze the life cycle analysis? The one of the very common software that is the CIMA Pro, which enable you to analyze the life cycle analysis, which you can know what is the overall life cycles emissions. CIMA Pro. Then for the process simulations, yesterday I already told you you can use the Aspen HYSYS or Aspen Plus, which is a very good tool to simulate the process simulations. So once you have that, your technologies output of your technologies data, because this one I didn't start from the previous part. Previous part is we conduct experiments to prove that the technology is working. Then after that, we continue with the life cycle cost analysis. Then for the cost analysis, normally what people do is very simple, which we consider the overall cost. It depends on you, where in which point you want to start, for the certain lifetime. For example, in this study, we calculate for 20 years, 20 years, which including all the potential costs, which the major cost is like your capital cost, your operating cost, maintaining cost, and also the in this case is the feedstock cost. Then the sales value and also the byproduct, if any. So we calculate based on all the present value with the certain you want to call it the discount rate also can, or interest rate also can. We consider which what is the future value. You want to calculate the future value at present. I mean, we call it the present values. So yep. Then after that, from there, we can calculate what is our payback period. Payback period is relatively simple, which how much you want to recover back, how many years enable you to recover back your total capital, total capital, which is the your total sales minus the potential costs, including all the tax and whatever. Then after that, what we do more compared to other, we do about the sensitivity analysis. So what is the sensitivity analysis? So because why? When we do any economic analysis, we base on the current scenario. But sometimes many things are frustrations. For example, the crude oil price are changing from time to time. So how if the certain percentage of the changing of the maybe the crude oil price or the raw material price or other operating costs. So what would be the impact of your total product price, for example? Then what would affected how much impact your total payback period? So maybe will we prolong your payback period or shorter? So this sensitivity analysis tend to add some uncertainty for those variables could be changed due to the international market or other potential situation happens. So this variable could be maybe your the crude oil price, the fixed stock price, or the oil conversion yield. Maybe you found out from time to time you improving your technologies. Maybe the year output might be better or might be less. Maybe you get the maybe relatively not really good raw material or the fixed stock. What would it happen? So we have one tolerance. So this might be affected your biofuel. Not necessarily the biodiesel can be applicable for any type of the products. I just use the biodiesel as the case studies for you to. So lastly, we also analyze what would be the impact. What type of impact? First is the energy impact because we want to offset what? Offset the fossil fuel, offset the fossil fuel. So what would be the economical impact? How many percent or how much the fossil fuel can be saved from the certain implementations of the policy? And this link to environmental impact. So how much the global warming impacts will be took place? So what is the potential carbon saving, or what is the potential of the ecosystem carbon payback period, or we can say the overall life cycles analysis of the on the environmentals. Why this? The net zero, that means what? Net zero emission, that means from the very beginning, from the production, from the point that you want to build a plant, or you want to build cultures, the certain crop lands, you have to give a lot of the energy input. If you create the emission as well, from that point, we want to calculate the overall life cycle, like what I mentioned. Not only calculate for the certain stage only, either the production stage only, or the consumption stage only, or the end user stage only, or even the cultivation stage only. So we have to consider the overall life cycle. But not need to be worried, because for the any life cycle analysis, you yourself can set the boundaries from which point you want to start. Maybe for the certain study, you just want to calculate the overall environmental impacts from your production only. For example, for your production part only, then you can set the boundaries about your production. That's it. Doesn't matter. So if you want to see the overall, if you want to build the plant, you have to consider the overall from the very beginnings to the very end. That one, maybe you need to consider set your boundary. This one, you are free to set the boundaries for any stage that you want to consider for the environmental impacts. Similarly, we also do some economical impacts, which we implement the certain taxation and subsidies. Then what would be the biodiesel break-even price when you want to propose the certain policies to your government? So you need to do this whole thing. What is the socio-economic impact? So what would be the, maybe might need some subsidies or the tax extensions and so on, for how many years? Maybe for the first three years, you have the tax extension, followed by the maybe implement the tax slowly to that industry, for example. So this all you need to consider. So what is the proposed detailed price? Maybe you can suggest to your government during if you want to implement the certain policy. You want to write the certain policy papers. So this is all the things that we need to consider. So this one result about the experiment I would show you. So this is what I showed you yesterday. So this is for the project lifetime of the 20 years, which we consider total is 21 years. 1 year for the construction of the plant, the preparations, which we also consider before. Then this 20 years is the production with the capacity, if not mistaken, the plant capacity we set as the 50,000 ton per year. then operate 24 hours, 24 hours, I'm not mistaken, yeah. I don't have the data here. Data already show in detail in the papers. So you can see, then this one we consider three types of the biodiesel production based on the availabilities in Malaysia. Of course, these all things are in US order on that time and based on the Malaysia scenario. Malaysia scenario. So yeah, that is the outcome that you can get. Then from here, we can get the total life cycle cost and total production cost. What is the potential production cost? Then what is the payback period? Based on the assumption that we make. So the assumption that we make, we put a certain percentage of the maybe percentage of the interest rate and certain percentage of the costs and the value. I mean the potential selling price of the biodiesel. So with this sensitivity is very important, like what I mentioned. Because during that time, the crude oil price is around 1,000 tons, $1,000 per ton. How if the price is increased and decreased? So what will be affect the total life cycle cost, or you can convert it. What will be effect of the per liter of the biodiesel that you you want to calculate. This one is the total life cycle cost. Then this one is the oil conversion year because typically during that time the industry can produce the conversion year up to 95%. Then in this study, we just assume that maybe just 90%. So what would the we are not taking a very optimal scenario. So if 100%, what is the potential life cycle cost? If higher percentage, higher year, I mean 100%, of course the overall life cycle cost will be lower. So this is how we can analyze these economic impacts for three types of the biodiesel. So this one, for example, this is some of the example. During that time, our retail diesel price, this is the baseline. Is, if not mistaken, during that time is 59 cents USD, 59 cents per liter. So that's why this is set. Then this is a crude oil price. So during that time, our crude oil price is around $1 per kg because it's 1,000 per ton. So this part you see the overall even with some subsidies the overall production price is much more higher. I still remember during that time after we calculate the overall biodiesel price is around 50% higher compared to the diesel price during that time. I mean this one 15 years ago. Yep, 15 years ago. But now it's almost same price. Same price because why? Due to the increase of the crude oil price. Because during that time the crude oil price is half of the today prices. So yep, this is what happens. So yeah, then we assume with the subsidies of the 10 cent, 18 cent because previously our governments are giving the subsidies to biodiesel because we want to push the biodiesel from previously we not implement any biodiesel and then we want to push to 20%. I mean during that time, then starting from the 5%, 8%, 7%, and to 10%. Right? Currently we are using just 20%. Yep. So after that, we see what is the total offset if the percentage of the fossil fuel will be replaced. Because this one we get the data from our transportation ministry, transportation ministry to get what is the total vehicles in our country. Then what is the either they are using the gasoline or the diesel fuel, because the biodiesel is to replace the diesel. So we just take the total consumption, transportation consumption of the biodiesel. Then we assume how many percent of the displacement. So what would be the impact? So this one, before we start this one, we also do the analysis. What type of the vehicles might be produce more harmful emission. So that's why we would suggest them to replace with the biodiesel. This one we use, this one is another study that we use the COPEX, this one COPEX to study what is the note for the buses, heavy duty vehicle, what type of the transportation will produce more emissions. Yeah, that's the thing. So that's why after that we propose few policies. We propose few type of policy. One of this to replace another policy that we propose is to during the time replace with the compressed natural gas. You heard before. CNG before. I mean, this one is 20 years back, and people tend to use the compressed natural gas. They slightly modify their car engines so that they can use the natural gas, because the natural price is much more lower compared to the diesel price. During that time, then many taxi they are try to convert into the natural gas, because taxi is, they run a lot. So compressed natural gas would give them a lot of the cost saving, around 50% of the cost saving. Yeah, this one. So that's why. So this one is towards if you want to propose any policy to the government. So this is what the government want to see, how much the CO2 can be saved. So how much diesel can be saved, how much then that needed. This one is very important, so that you can get a sustainable raw material or feedstock. Then this one is like I already showed you yesterday. So if the crude oil price is what price, then you see, if we just assume everything is still the same. If around the crude oil price is around nearly 100, then if the crude price is around 1,000 per ton, so you see almost break even. And this scenario, if there are nothing changed with the production cost, nothing changed with the technology of the conversion year, you see, because previously we are in this line here, this point, a lot of subsidy needed this point. So currently we are very close already. Yep. So that's why this chart is break even price is very important, so that compared to the certain technology. So so with this I conclude that this is how we can do the cost analysis and also the environmental impacts after we propose the certain technology. Yeah, so that the investor or the government policy maker can know what will the impact of your technology. Yep. So any questions before I continue with the syngas or the hydrogen gas? Yes. Oh, discount rate. Oh, yes, correct. Discount rate. Discount rate. Yeah. This one is toward the life cycle cost. Life cycle cost is you can convert to the biodiesel production cost. Yes. It's co-duration. Yeah. Yeah. Social impact is like the acceptance of the end user or whatever, right? And also the stakeholder, the potential stakeholder like the car manufacturer or whatever. This one we didn't do any survey analysis. And that one you can go through the survey and analysis. Yes. Yeah. You still have a question? Yeah. You finish first. Yeah. No. I didn't mention. No, the motorcycle is this one. No, I didn't mention the motorcycle. This one is I mentioned what type of the transportations have how many emission. Which one have the emit highest emission? I didn't say yep. Then from here we can propose a certain technology that can offset the emissions. Because during that time we propose 5 policies, including the biodiesel, replacing with the biodiesel, then maybe enhancing with the public transport. Then for each policy, we will do the impact. So what is the impact and possibility? Yeah, but this one is purposely focusing on the biodiesel. Yep. This is to know what is the emissions come from each sectors. I mean each transportation type. Yep. Yes. sensitivity analysis. Yep. Yes, because why? Because this one we based on Malaysia scenario. We not involving any raw material, anything that import and export. Yes, we might export the biodiesel whatever, but we are not considered it. Yeah. Yes, correct. Yep. If your targeted client is overseas or other country, yes, you might need to know what is the exchange rate. But currently, we are in this study. We also calculate in the USD because US dollar is the most acceptance currency during that time. Yep, during that time. Yes. Yes. I understand what your question. Yeah, this is the very tricky question because you know it for the it you really need to see when the government want to propose or want to promote or any technology, what is their direction, what is their main purpose. For example, now if your government want to have the hydrogen energy, no matter what is the cost, they want to develop the hydrogen energy. Why? Due to the maybe the environmental impact or whatever. That one, maybe you can work toward the environment, but don't forget about the economical impact. You must make sure it is economical feasible. It's compared to the current technology. But maybe the focus is more on the environmental impact. But how to make to optimize the cost as well. Yeah, with a certain technology. Yeah. Yeah. Find the buyer. That means what? Import. Yes. Yes. Yeah. Import. Okay. Yeah. 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 Mm. Yep. Yeah, so that's why you need to know what is the initiative of your government or the second government want to implement the certain policies. Yeah, that's the thing. Because in many cases, if one country want to implement a certain policy, especially the green energy policy, they want to have their market, the certain market share. So that's why the first the final crucial thing is what need to make the technology as economical possible. As economical possible. Why? This one can attract the investor. I mean the local investor or even the foreign investor to invest on the certain technology, especially when they want to in the development stage because the investment for the infrastructure is relatively high. So basically, during the very initial stage, the government will put in a lot of investment. The government themselves, they will lead first for any type of policy. But then they will give the tax exemptions to the certain companies or whatever. Then after that, you have to make sure the technology is feasible. I mean, sustainable, feasible and sustainable. How you going to sustain after the subsidy is removed after the certain year because the government give the subsidy. They will say, oh, the subsidy is just a 5 year. Yes, subject to renewal. I mean, I think same with any country. Yep, that's the thing. Yep. Ah, uh, we don't have any tool that integrated to LCC and LCA, but they are integrated. Integrated that means what? First, you must know your technology. The technology will provide the data input for both LCC and LCA. LCC and LCA. So one of the tool that I'm using, I mentioned to you yesterday. I told you is the what? The S-Band Plus. The S-Band Plus, after you do the simulation of your technology, you can know the overall production material that you needed, including how much energy input and how much energy output and what is the potential emission will be produced. So from there, you can extract the data from there, then you can calculate your cost, do your cost analysis and as well as the emission analysis. Yep. Then just now I mentioned the SIMA Pro. SIMA Pro only the tool have a lot of the database, then you put in your process, then they can estimate what is the potential emissions for the overall process. And that one only can get the the emission analysis. Yep. That's, yeah. LCC, there are no any certain tool because it's based on your business model. But because I'm not the business person also, so we just do the Excel, right? Excel based on your cost, yeah. Cost benefit analysis, cash flow, yeah. Yeah. Gabi is same with the SEMA Pro. Same with the SEMA Pro. The main aim is to calculate the emission. But from there, as I mentioned, from there you can extract some data and to convert into the dollar. Yeah, to convert into dollar. Yeah. Main dollar, I mean the economical impact. Yeah. Gabi is same like the SEMA. Not to say same. They are similar too. Gabi and also the SEMA Pro. Gabi, I think not mistaken is free or very low cost. Yeah, free, right? Gabi is free or what? Oh, paid now. People there, I think it's free. Open LCA. Yeah. Most of the academic license cannot be used for commercial license. Cannot be used for the industry. Yeah, this one you have bear in mind. Yes, because academic license much more cheaper. I can tell you, maybe some of the license is 1/10 of the price only. You know, some of the software, is relatively very low cost. Yeah. Yes. Oh yes, for the LCC is very easy. For the LCC, but for the LCA, last cycle analysis, might be very complicated because we don't have the emission data, you know. What is the emission data for the certain technology or certain, for example, you want to go through the turbine, go through a compressor, so what is the potential emission? We don't know. Then they have a lot of data bank, so that's why. For the LCA, yes, definitely, no, mostly we do on Excel only. Excel, and this I myself do on Excel only, I mean the LCC. Yeah. Until now, I also do on Excel only. But the LCA, I use the different software like I told you the SEMA Pro and also the S1 Plus. S1 Plus. Yeah. Currently, I using the S1 Plus. But S1 Plus is not the LCA. I mean, it can certain process only, not the overall. Not the overall. Yeah. Not the overall. Yeah. Because S1 Plus is the process simulation, just the process only during the production, during that process only, not for the very beginning until the consumptions. Yeah. And then you simulate the consumption. The consumption also go through maybe the gas turbine or whatever, and this one you can put in. Maybe if you want to put in into vehicles, whatever, no, they don't have. So, yep, that's the thing. So, any other questions? No, I continue with the last part, which is the yeah. Yeah, the last one is about the hydrogen and also the syngas. Because for the past few days we keep discussing about the liquid fuel, solid fuel, liquid fuel and also solid fuel, liquid product and solid product. So today we would like to discuss about the gas products, which is start with the syngas first. So how we going to implement or utilize our waste management in order to get the syngas. So waste management, waste treatment, we have many methods. So you have the very typical method which we dispose directly for the landfill, disposal directly for the landfill. It will cause the environmental impact, very serious environmental disaster. So we also have the not currently in many countries. We also have the incineration plant, which we burn it directly, but it will produce the greenhouse gas. But now the incineration plant is already improved. They can recalibrate some heat to generate some electricity, but still burning. So the greenhouse gas will be produced. But most renewable way or the new way, the latest way is more on what the biological treatment or the thermal treatment, which we are keep discussing these few days. So the biological treatments normally we will get the biogas, correct or not? The biogas. Then the thermal treatment we can get the syngas, and both this biogas and syngas is content of what the hydrogen gas. So this the hydrogen gas is currently focusing. We are focusing now because the hydrogen. Why focusing on hydrogen gas? Is one of the future fuel. Why the hydrogen is a future fuel? Yeah, no. First is no emissions during the combustion. Yes, correct. No emission during, and also the high energy. High energy value per unit. Per unit. Yeah, it's high value. So is the current focus shift to the hydrogen energies. But before we go to the hydrogen energies, we look at the syngas first. Syngas. Syngas, what is a syngas? It's a synthetic gas. Go through the, as I told you, go through the what go through the thermochemical process from the biomass. So the main product will be the CO and CO and also the hydrogen. Sometimes it will produce some methane also, and also the CO2. So normally, it is normally if from the organic waste, which is the biomass, most of the biomass, it will produce 40% of the hydrogen, maybe 30% of the CO, and some percentage of the methane gas, and also the other type of gas. So this is the syngas. So the pathway for the syngas. So after you produce the syngas, what you can do for the syngas? Okay, normally the syngas will be produced through the gasification process, thermochemical conversions, but mainly due to the gasification process. When I talk about the thermochemical process, the pyrolysis process will be produce the syngas as well. But as I discussed yesterday or the day before, the pyrolysis process, our main product is what? The bio oil or the solid product. But no doubt the syngas will be produced as well. But for the gasification process, their main purpose or main aim is to produce what? The syngas. The syngas. Then what you can do after you get your syngas? So first, the syngas can be converted into the methanol. Methanol. And also the syngas can be go through the generators and also the boiler directly to produce the steam and power to generate the electricity. Directly. Then this one to go through the genset or to go through the internal combustion engine, or can go through the your fuel cell. Then syngas is the hydrogen, this hydrogen, they are more application for the hydrogen. If you can use in your fuel cell, and also the transportation. We have the hydrogen vehicles. Then can go through the refinery as well, and also the hydrogen power plant as well to generate the electricity as well. So and if the syngas go through the feature stroke, this is a very typical technologies to convert into the what? The diesel or the green diesel, green diesel or the gasoline products. Then for the methanol, of course, for the methanol, we have various applications as well. Then can be produce the ethanol as well. So this is what the syngas is important, because they have many other applications. But how we going to get the sustainable syngas? That is another problems. So yeah, this is a question. So how much waste is there to be treated? Because keep treating, how much to be treated? What type of the waste? What type of waste you want to treat? Because different type of waste, maybe you might use different technologies. So what is the chemical composition and what is the calorific value? If because if we want to use the syngas as the what? as a fuel, correct? Mostly you see most of the application is we use as a fuel. So what is the characteristic value or the energy contents for the waste? So what is the particle size and moisture, etc. So the waste that can be treated is many things, the municipal waste or the commercial waste, sewage waste or the agricultural waste or the tire waste and etc. So how much is to be treated and how we can get this sustainable feedstock or raw material this, or we need to consider to be asked before we continue. So when we talk about the thermochemical treatment, so there are two types of the biomass. One is the biological and one is the non-biological materials, because some of the non-biological material have relatively high energy contents. You know why is that? The plastic, the plastic waste, the plastic waste, the plastic waste, and generally you see the plastic waste have the very high heat content or the energy contents. So that's why currently maybe people they try to convert this plastic waste into the syngas or hydrogen gas. So for the biology waste, it's just like the our agricultural waste, our food waste, then this and so on and so forth. With the average heat content, heat values is maybe half of the total non-biologic. So yeah, then let's see how which one you want to convert. Yep. So the thermal waste treatment, this one I already discussed. So they divided into the three categories as usual, which the pyrolysis we keep discussing yesterday and the day before. So for the syngas, basically we go through the gasification because your background, your hydrocarbons in your biomass waste into the syngas by control amount of the oxygen, by control about the oxygen with some oxygen. So normally, typically, the temperature is happen around 1002, starting from 1002 to 1006 for the gasifications. And for the pyrolysis, with the average temperature of the 500 plus minus 500 degrees C. So their main product is what? The char oil. Of course, the syngas will be produced as well. Syngas will be produced as well. Then this one is a combustion. Combustion directly we throw into the what boiler or whatever to generate the heat and electricity directly. So yeah, that is the fuel pathway. But in order for us to get the syngas, the gasification is a preference. Gasification is a preference technologies if you want to get the syngas. So this is the what? This is the main chemical reactions go through the gasification. Just now I mentioned why we need some amount of the oxygen. So where is the oxygen come from? So normally for the gasifications, we put in some steam, heated steam, so that heated steam to have the H2O, so that they can react and can generate what? Hydrogen. The hydrogen, our main product would be focused on more on hydrogen. Of course, the CO will be produced. So just now I mentioned CO and hydrogen are the main products. So yeah. So this is the one of the example of the biomass go through the gasifications. So normally we have air or steam, either the air or steam. This one is using the air directly to provide with the O2. And sometimes we can use the heated steam, which is H2O, because it's put toward to produce the hydrogen from the H there. Then we have the raw syngas. Then first stage of the clean up of purifications. Then go through a second stage, then we can get the hydrogens. Then some of the CO or other type of the syngas can be produced as well. Then the pure hydrogens can be used in what? In the fuel cell and also the hydrogen vehicles, fuel cell or hydrogen vehicles. Then the syngas can go through the plant to first is to generate this one is generate electricity and this one go through and generate electricity directly, or go through the process plant to have some liquid fuel or the green diesel or green gasoline, green diesel or green gasoline. Then after that, it can the recovery waste heat can go through the boiler. Then we can have some with the CO2 separator. We can have some exhaust gas and or the CO2 can store the CO2 for the commercial purpose. Then goes through the steam turbine and generators to produce the electricity. So this is one of the very typical gasification process, which the main aim might be produce the hydrogens, but other byproducts can be used as different applications. So yep. Yeah, that is about syngas. So what we want to focus is the hydrogen gas, correct or not? So hydrogen gas, why hydrogen gas? Why hydrogen gas? This one is I also obtained from one of the study from India. As I told you before, hydrogen energy or the fuel cell energy already discovered in 1800s. In year 1800s, we already know how to produce the hydrogen and how we going to use the hydrolysis process 18 years ago. But still, we didn't utilize the hydrogen until now, because during that time, when, if not mistaken, is the Sir Henry, he discovered the electrolysis process. Henry William, if not mistaken, I don't know, you can check back. Henry William for the electrolysis process. Then during that time, they want to use the fuel cell, they want to use the hydrogen, but make it fear. Why? Because sooner and later we discover the oil and gas, which much more efficient, and then no need any costs can be obtained with no any costs, because during that time the hydrogen and also fuel cell is one of the energy sources. So until today, we still are not using. So because why? Because how we going to produce the totally green energy? Because if you want to go through the electrolysis, what is the electrolysis? Anyone still remember? Because during your high school you learn about the electrolysis, right? What is about electrolysis? Yes, separate the hydrogen and oxygen, right? You need what? You need the electricity, to separate the H2O, to separate the water from water. So you need to provide with the electricity. So electricity, so we still need some electricity. So how we going to produce the green hydrogen? That is the question. So that's why make it the electrolysis process is not working just until today. So yeah, but currently many government including this one obtained I mentioned obtained these studies from one India. They mentioned that the India want to have the energy independence like 2047. I'm not sure. I'm asking you. Yeah, it's my questions to you. Then to achieve the net zero by 2070. Is it true? That's a plan, That's a plan. Yeah. Because this one obtained from one of the studies from Indian scholar. So yeah, that's the plan. So that's why. Start from that time. Then from time to time, we found out that the hydrogen energy have more application. Just like what I mentioned just now. We can have the fuel cell vehicle. Then we can have the hydrogen what to call it? hydrogen fuel station and hydrogen plant directly. We can generate the electricity from hydrogen power plant, from power plant directly. And we can use the green energy to produce the hydrogen, which we can convert. You see, some of the country or the region rich in the solar, so they are unable to store their solar, right? Currently they just store in what? Store in battery, but the capacity for the battery storage is limited. But no doubt this is one of the very good storage medium. Then in Australia, how they store? In Australia, they have very big land with the solar energy. So how they store their energy? They store their energy in terms of fuel, instead of the battery, because battery is very heavy and hard to transport in terms of fuel. So they convert the solar energy, the surplus of the solar energy, they will go through the electrolysis, then to produce the hydrogen and store the solar energy in terms of the fuel. So this is the one way of the storage of the energy. So that's why we have the solar power hydrogens. So yep. So the growth trend, because currently I guess all of you already know, mainly focus on the European country or IIA. They are focusing more on the hydrogen energy, including the Japan, Germany, and US. These three countries are the top consumption of the hydrogen energies compared to other. But the hydrogen currently is play a very important role in energy transition, because now we are in the energy transition, like what I mentioned. So currently the industry 4.0 took place. So what is the energy, sustainable green energy that can replace the fossil fuel to reduce the emission? Yeah, hydrogen energy might be one of it. So yeah. So this one is to give you a brief ideas. How much hydrogen energy can be produced from the different type of the waste or raw materials. For example, the municipal solid waste can produce around 80 kg of the hydrogens. The 1 ton of the biomass can produce 50 to 100 kg. You see the capacity is less than 10%, less than 10%. So yep, currently then the plastic is the highest. The plastic is the highest. So people tend to convert the biomass from the plastics into the hydrogen, because why? Is here the highest. So now people is tend to process or gasifications with the plastic waste, to produce the hydrogen energy. The industry waste also 50 to 100. Yep. So yeah, this is the technology to produce the hydrogens. This one is not all the green technology. I just show you all the potential technology that can produce the hydrogen. Currently, our hydrogen production mainly depend on what? Natural gas. Still from the natural gas, which basically from the methane. Methane go through what? Go through the steam deforming, steam methane deforming process to get the syngas and to get the hydrogen, because this is currently most sustainable methods. So what they do on that, because this is not green, right? Correct, not from the fossil fuel, but currently I can say at least more than 70% of our hydrogen are from this process. Currently what they do, because what happened? What happened to the steam methane forming? Anyone know? Steam reforming from the methane. This is one thing, but we have abundance of natural gas. You don't worry, because more and more oil and gas plant recover. So yes, 20 years back, people keep saying the oil and gas will be decreasing and reducing, but not nowadays, because no one saying this thing anymore, this statement anymore, because there are more and more oil and gas plant discovered. But we are shifting to the green energy due to what? The emission factors, emissions. Because why? Because the steam reforming process will produce the CO2. That cannot be avoided. Cannot be avoided. But this is a very effective process to convert the natural gas, which is the methane, into the hydrogens. No doubt. So currently, what they are doing with the steam reforming, they just put the carbon captures, the carbon capture unit to capture the CO2. But many typical plant they still are using just the normal steam reforming. So, yep, these three. So currently, the hydrogen gas mainly depend on the natural gas and also the coal. Coal is what? Coal, why? Because some of the country, they don't have any oil and gas. So they are producing their hydrogen gas using the coal. For example, like China, they have abundance of coal, but lack of the oil and gas. I'm not sure it's very high because oil and gas and natural gas methane is a CH4. CH4 is totally can say is very efficient. Only the methane then can produce the hydrogen directly. So it's a very high CH4 and to H2. It's very high. So it's currently the world is producing by using the hydrogen. But now, yeah, back to our question. What is the sustainable pathway to produce the hydrogen? We can go through the biomass. This is the topic that we want to discuss. The biomass from biomass materials. Then the biomass material, there are two pathways. One is the biochemical conversion, biological conversion to get the biohydrogen directly, or can get the biogas. Biohydrogen and biogas. Then go through the thermochemical conversion process like gasification process. We also can get the syngas. Gasification process can get the syngas as well. So algae from the sunlight, then go through the biochemicals, it can produce the hydrogen as well. Then the solar and wind go through the secondary electricity, go and then through the electrolysis. This is the electrolysis, and go through the green electrolysis, then can produce the hydrogen as well. So this is the potential pathway. Later on, I will show you what is the color of the hydrogen. Color from hydrogen, from very dark color until the green color. What is the process that, for that? Yeah, this is another challenging. So that's why people prefer to use a natural gas. No any other type of the biogas or CO or whatever. Yeah, because it's a very pure hydrogens from the methane. Natural gas are particularly from the methane. Yep. So that's why if we are to go through the biomass, a lot of the other gas that we produce is make us very hard to separate as well. This is another problem facing by the biomass gasifications process. Yeah. Even though go through the biological process, the hydrogen here that can get less than 10%. Imagine less than 10%. Biological even less, but from the gasification maybe still have 10%. Still have 10%, but biological definitely will be less than 10%, maybe 5% or even lower. Some of the process even lower. Yeah, that's the thing. Yep. So you see, in order for us to produce the green hydrogen, we must have the overall ecosystem. First, we must have the totally green production process. Right? Not start from green production process to produce the hydrogens. Not only look at the end user and also the power generation only. End user and power generation only, because end user and power generation, because we know that when we use the hydrogens to turn into the energy, definitely is very clean. It's very clean. But the thing is how we can have the sustainable green hydrogen productions. After it produced, storage another issue. Storage another issue. Transportation is another issue as well. This is all the boundary that we need to break through, and also we need to disrupt this whole ecosystem so that we can have the sustainable green hydrogens. Hydrogens. And after that, go to the end user. Yes, end user, no problem. I mentioned during the consumption, very green, very green. Then after that, from this, then we can generate the green electricity or power, and so that we can have the totally green hydrogen for the overall life cycles or ecosystem. If not, you are green in the end user or the consumption part only. How are you going to produce the green energy? Yeah, that's the thing. So the first challenges is coming storage. This one storage, because the production technology. Just now I briefly show you there are a lot. Correct not? And the main challenge is come. Storage. You see. The storage. The storage in the gigajoule of each field. You see, for the hydrogen. This one is this all is hydrogen. Liquid hydrogen. Compressed hydrogen, compressed with different pressure, different pressures, compressed with the 700 bar and 350 bar. You see, the storage volume is relatively very small compared to the diesel and petrol or diesel. So storage, yeah, that's the thing. Storage of 1 kg of the hydrogen. You see. I need 1001. Then if not, you need to compress it. If not, you need to store it at a negative liquid, negative 200 something degree. Why negative 200 something degree? Hydrogen is in what forms? During the what atmosphere temperature or ambient temperature? In gas, right? In gas form. So that's why. The volume for a gas is very big, right? Compared to the liquid and compared to the solids. So that's why we need to know this one. Go back to the fermenter. So this is the phase diagram for the hydrogen. You see here. From the degree C2 to degree 3, it is in the gas form. Up to the 10 bar. You see, if we want to at the atmosphere pressure, we want to maintain it at the liquid form. We need to get rid negative 240 and below. If not, we need to compress it. This is liquid. This one is compressed. Or the gas form. Very high pressure. So that's why. So that's why the storage is one of the issue. Yeah. So is what the compressed and liquids. We have these two typical method. One is the compressed gas. Another one is the liquefied. Must be below negative 280. 280, which is 80 degree, lower than the liquefied natural gas. That's why need very low temperature, and compress, need to compress up to 350 to 700 bar. This one is very high compress. So that's why. So now there are many studies also starting to find what is the suitable. I think I mentioned it a few times last few days. Storage material for the hydrogens. So now many studies they found I found some certain materials. Certain material can store the hydrogen, good material, but how they going to extract, store and extract? Yeah, that's the thing. So another way that we can store is we convert the hydrogen to another form. So that's why people tend to convert into the methanol. And then after that, when you want to use, then recovery back. Yeah. During the consumption. So that's why you see fuel cell. You know the fuel cell units. Normally, we are using the hydrogen because H2 plus oxygen equal to H2O. Then the energy will be generated, correct or not? But Now we have the methanol fuel cell because methanol is easy to carry, easy to store. So that's why we can use the methanol in the fuel cell also during the consumption in the fuel cell. We can use the methanol directly as well. But if you use the methanol, I mean the C and CO, CO and CO2 will be produced. Yep, C and CO2 will be produced. Correct. So yeah, these are the challenges. The first challenges. Yeah, correct. And storage, no doubt. And then study also, this one, stress hydrogens with a very high pressure. So we need to find the suitable materials that can store the hydrogens. So this is the transportation. Just now I mentioned transportation. You see, in order to transport 1500 gigagram of the petrol and LPG, only you see 2.2 truck, and this one is 3. But you see, for the hydrogen, you need how many? Even this one compressed to 700 bar, 13.4. This one is compressed to 250, double. Yeah, this one. Then this one is liquid form. Liquid form. That's the thing. Yeah. So storage and also the transportation is the main issue they're facing by the hydrogen energy. So this is the hydrogen production. Maybe break for 50 minutes. Then we come back with the hydrogen production technology. So there are different type of the hydrogen production technology I'll introduce. Okay, any questions before we take a break? So if not, we take a break now. Then we come back in 50 minutes. Okay.
Hello.
Okay. Yep. I think we can continue. I still have a little bit more here to continue, which basically I will share with you with the potential hydrogen production methods, different hydrogen production methods. At the same time, I also show you some of the studies, some of our studies about the hydrogen energy. Oh, thank you. So the first method is a very traditional method, which is the hydrogen energy from the coal. This is a typical method. So currently, around 25% of hydrogens are produced from the coal, and another 70% are produced from the what? Natural gas. Natural gas 75%, and coal 25% make up around 95%. Just 5% are from the another renewable sources. So what they do is the process is typical, very simple, which they using the gasifiers to produce the raw syngas, then go through the reactive and separator to remove the other impurity gas, then to produce the syngas. Previously, the production of the hydrogen, even from the coal or from the natural gas, is without the carbon capture unit. But currently, from this recent 5 years, so they will add one carbon capture units in order to capture the CO2, because hydrogen's energies from the coal and natural gas, they will produce a lot of the what? CO2. CO2. So they will capture the CO2. But with this, the overall cost for their productions is make it higher, which is around 1.9 to 2.4 USD per kg of the hydrogens, which you see. You look at the price, you know it is relatively very high compared to the natural gas and other type of the fuel. In China, they can further reduce to 1.6 kg, $1.6 per kg, because they produce a lot of the coal, their coal. So that's why. This is the what, which is the, yep. But still, the overall production costs are still lower than the cost than the hydrogen produced by the water hydrolysis, because water hydrolysis is what? The green energies, more green energy. The cost is highest. So this is the applications of the hydrogen across the, this one I should discuss this one first, across the sectors. So after we produce the hydrogen, what is the potential applications? First is for the industry process, for the refinery process, or ammonium methanol synthesis, or direct iron for the steel production. So there are many other industry process that needed the hydrogen energies. But at the same time, if we use the hydrogen energy as the hydrogen as the energy applications, first, like what I mentioned just now, can be produced the electricity directly through the power plant generation. Either it can produce the off-grid power supply for some rural area. That is very good. Off-grid power for the rural area, because if some rural area is more than, I don't know the situation in India, but in Malaysia, if the one rural area is more than 25 kilometers, it's not worth to connect to the grid, because the cost is much more higher. So it's better to produce the off-grid stand-alone power supply. So hydro energy can do that, the off-grid energy supply to some rural area that they are not grid connected. At the same time, it's also can be used as the large-scale energy production and storage as well. Then secondly is power to fuel. The hydrogen energy is one sort of the renewable gas. Then they can convert into the synthesis fuel and ammonia fuel. Yep. From the hydrogen energy, it can convert it into the other fuel type. That's what I mentioned. Because if we store in the hydro energy, the storage might be one of the problem. Storage and also transportation is one of the problem. It can store in another form. So currently, people tend to store the hydrogen in what form? Ammonia, in methanol, in other type of the form of the fuel. So after that, when they want to use, they convert back, or they can use it directly. So from the power, can convert into the fuel, other type of fuel. Can be used using in the industry, for the heating in the industry and also the residences or commercial heatings. Lastly, can be used in the transportation. Currently in European, we already have the hydrogen fuel cell bus, bus or heavy duty vehicles. At the same time, there are some aviations and also the train and also the shippings also shift into the hydrogen powers. So it can be used in the transportation sector. So this is the fuel applications for the hydrogen energy. Then the second one is what? The using the natural gas. First is using the coal, then second is the natural gas. So natural gas, hydrogen for natural gas that I mentioned just now is account 70%, which if you have produced a lot of the CO and CO2, CO and CO go through the steam deforming method. So currently the industry are using the steam deforming method. So whether they connected into the carbon capture unit or not. Some they connected into carbon capture unit, some they are not. So that's why it will produce a lot of the harmful emissions. So currently, so 96% of the steam forming are from the fossil fuels. 96%, then 49% are from the natural gas, and 29% are from the liquid hydrocarbon, and 80% are from the coal. If total 96% just now, like I mentioned just now. So from the natural gas, there are still another two methods from the methane pyrolysis also. From the methane pyrolysis is able to convert into the hydrogen gas as well. The methane pyrolysis, as well as the electrolysis process. Just now of the methane. Just now I mentioned to you, correct not? We can use the methane directly into the fuel cell to separate it into the hydrogen, oxygen, and also the CO, carbon monoxide or carbon dioxide. If we are using or if methane, no, methane, yeah, carbon monoxide and carbon dioxide as well. Yes, if using the methane. So yeah, completely oxidized to the carbon dioxide and water. Yes, correct. Then the main product might be the hydrogen and also the carbon monoxide. So if you are using the nitrogen as a carrier, then the nitrogen will be produced as well. Then the small amount of the CO2, CO2 will be produced if the complete combustion took place, because normally we use just a little bit of the oxygen. If sometimes the combustion might be happen in other compound. So that's why if the hydrogen produced from the dirt fossil fuel, they will produce a lot of the harmful emissions. Now, this is what we concerns. So we can produce the hydrogen from biomass. The biomass, this is the topic that we are keep discussing. The biomass, there are two methods as I mentioned before. First is the thermochemical method, which normally we are using the gasification process to produce the hydrogen. But at the same time, we also can use the pyrolysis, which we can use the lower temperatures to produce the syngas. Then the hydrogen gas might be produced as well during the process. So the aqua phase can be converted into the compound and also the hydrogen as well. Or the aqua phase normally we can treat it as the biogas as well if go through the pyrolysis. But at the same time, it also can be converted into the what? Into the green diesel or green gasoline. So go through the biological method. So there are two potential biological method. One is the fermentation. Normally the fermentation here is go through the dark fermentation, and also the photo fermentation. From the dark fermentation and photo fermentations from the biomass, the biogas or the biohydrogen can be produced. So of course, each process depend on nature of the enzyme that we using. They are using the enzyme for the different biomass, using the different enzyme or different yeast, different enzyme and different yeast and different type of the process might be took place. Then it will form the hydrogen. But at the same time, the other type of the biogas might be produced if we go through the biological process. So then the third process is about the electrochemical process. Electrochemical process is just like the fuel cell process. It separates between the waters, the waters or the wastewater. Normally, we use the biomass from the for the electrochemical process is we using the wastewater, wastewater or the sewage water or other type of the liquid form of the biomass that contain of the some bacteria or biological organic compound. Then we can go through the electrochemical process to produce the hydrogens. So yeah, so what type of the biomass we can using? First is the agricultural biomass waste, which most of my study are using this one. So sewage sludge, plastics, super solid waste, and also the hospital waste. I go through, as I told you, I go through three process. Then the last one is the electrochemical process, which we can produce the hydrogen as well from the liquid biomass, So this one also some of the process to produce method to produce the hydrogens from the chemical process, the biochemical process, and that chemicals that fermentation process to produce into the hydrogens. So go through the thermochemical process. If go through the pyrolysis process, then we have to go through another the Fischer-Tropsch process to produce the hydrogens. Then the syngas can be directly separate. Then to separate out the hydrogens from the syngas, then to get the pure hydrogens. So biochemical process, then from the alcohol, the methanol, or it can be converted and reformed into the hydrogen as well. So that fermentation can produce the biohydrogen directly or the biogas. Then another method is to produce the hydrogens from the renewable energies, which these three types for me is almost similar, which the concept is the what fuel cell concept, just different type of the fuel cell, just a different type of the fuel cell, because we have the photon exchange membrane or solid oxide electrolyzer fuel cell and alkaline electrolyzer fuel cell. All is just like the fuel cell units. So if with this method, it's a relatively clean method compared to the from the fossil fuel. So yep. So yep, this is the three type of the process that can produce the end product with the hydrogen and oxygen only. This is the so during the process is totally clean. So at the same time, we can use the what renewable energy and renewable powers to for your electrolysis process. Yes. Yes, costly. True, because we need the energy input to separate it. Yeah, correct. Its cost is much more higher is compared to the fossil hydrogens. For the fossil hydrogen example from the natural gas. Natural gas for the natural gas go through the steam reforming is much more cost effective. Yeah, much more cost effective. Yeah. So, hmm? Electrolysis. Electrolysis is costly. Electrolysis is I can say is a very costly compared to the compared to the steam reforming process from the natural gas or from the methane gas. From the methane gas, yeah, this is relatively costly. Yes, correct. First, the initial cost is very high really, for the electrolyzer. Second, you need a lot of the electricity to power up to separate the hydrogen and also the oxygens. Yeah, so that's why some of the country they using the renewable power, which they use the solar power. That's why this is what I mentioned to you. Solar power, then to convert into the electricity to power the electrolyzer. That one. That one also make it overall production cost might be lower, but still the initial cost is higher because you need to install the solar energy as well as the electrolyzer. Electrolyzer itself is one of the expensive technology. I mean nowadays might be the cost might be lower and lower in the future. Yeah, in the future, more and more research going on that. At the same time, all this technology, we need one thing, membrane. A lot of the study on the membrane, right? This is the usage of the membrane. Yeah, how you produce the green sustainable membrane and useful membrane. That is the usage because we need a membrane for the electrolyzer. For the electrolyzer, the membrane is one of the consumers that you need to change from time to time. Yeah, that's the thing. It's another cost from the electrolysis. Yeah, but the overall process is green if using the solar power. It's using the solar power. Yeah, it's green. So Australia, they are using this method. They export the hydrogen to Japan because the demand of the hydrogen in Japan is very high. Yeah. This one is a color. Yeah, this one is a very interesting things, which the I go from this one first. The hydrogen production by color. You see, if the from the coal, we name it as a black color. The color is mean that the green hydrogen we can say is totally green. So don't don't have the misconception that when you heard about the hydrogen energy, it is the totally green. It is not. It is not. I need to mention it again and again. Hydrogen is green during its consumption, which when you consume the hydrogen to produce the electricity to power the certain thing, yes, it is very clean. There are no any emissions that we produce in your generator or in your vehicles. If you are the what the hydrogen power vehicles, there are no any CO2 emission, but the process to produce the hydrogen is emits a lot of the harmful emissions. So that's why we name the hydrogen production by color. By color. Only green hydrogen are totally clean. So don't have the misconception that when you heard about hydrogen energy, it's a green energy. It's yes, hydrogen is a green energy during consumption, but you need to make sure the production also be clean. So just now I mentioned that currently 90 to 95% of the hydrogen production are from the coal and natural gas using the gasification process as steam reforming, which steam reforming is currently account around 70% of the total hydrogen productions, which is not really clean. We name it as the gray because gray hydrogens, but due to the technology improved and people found that the production of hydrogen produce a source of CO2. So we have the blue hydrogen, which the steam reforming process they embedded and also install with one of the carbon captures, which they able to capture around 80 to 90% of the CO2, make it little bit more clean because they just capture what to use about for the CO2 that you capture. So that's why we name it as the blue. You see the color turn to be become lighter and lighter, then until the green energies. So methane from the methane go through the pyrolysis little bit more green. We name it turquoise color. Then we have the nuclear power. Nuclear power hydrogen. Nuclear power hydrogen. This one go through the electrolysis. This one is sulfur ion cycles. Yellow color, pink colors. Then come to the renewable energy. From the renewable energy, then powers the electrolysis. Make it totally green process. Then another one is the from the biomass. Go through the dark fermentation process to produce hydrogen. This one is relatively clean as well. But the year for the electrolysis, from the biological treatment is relatively very low and slow. So we cannot get the sustainable enough sustainable hydrogen. But this all process we can get the sustainable hydrogen. So that's why we put it here. So they still have many process that can produce the hydrogen, but we cannot produce the sustainable in hydrogen. Yes. What? Sorry, come again. Correct. You use the biomass. If you use the biomass for methane generation, oh no, no. Why you all methane? Yeah, that one is not consider. That one is consider this one already. Because yeah. Oh yes, correct. This one is a methane, but the SMR will produce the CO as well. That one for me I will classify as the blue. As long as you use the steam reforming with the carbon captures, that one is the blue already. Blue already. Blue is a blue. Yeah, it's a blue. Unless now they have another technology. We are using the another new technology, and that one I also don't know how to classify. They use the at one pyrolysis. The at one pyrolysis with the catalytic at one pyrolysis, they can convert the carbon into the carbon nanotubes directly. There are no any carbons, or maybe the minimum carbon will be produced that one. So currently these are new technologies that happening now. So one catalytic pyrolysis from the methane, from the methanes. This one is just a normal pyrolysis. What are it at one pyrolysis? Yeah, from the methane. Then the carbon, the carbon that produce, they convert it into the solid carbon, which is can be converted into carbon nanotube or carbon nanofibers. Yep. Yes. Yeah. Basically, the CO and CO2 will be produced. CO and CO2 in all the process, especially gasification and SMR. This one, because these two process are also the similar process. This one only they capture the carbon only. Yeah, they capture back. So all the process beside this one, electrolysis no, yeah, beside this one. This one, but they're using the nuclear, so it's not nuclear somehow, because it's somehow some people say green, some people say not, so that's why they classify as a pink. Yeah. Same. Can say you can say same and different, because there are many carbon capture can be use the same technology as well. There are many carbon capture technologies. Yeah, you can use the same carbon capture, so you can say same, you can say different. See, depend on what is the carbon capture technology you are using. Yeah, can be same. Yep, can be same. So that's why this is the classifications by color. So next time we heard about the hydrogen energy, you know how to ask whether your hydrogen energy is green or sustainable or not. Yeah, sustainable is sustainable, because like coal and methane can produce continuous hydrogen energies. Yeah. So yeah, this is a little bit more details about the classifications about the classifications because you see the green hydrogen is only produce what waters and also the oxygen. So it's a totally climate neutral hydrogen, carbon neutral. Then the gray one, you know what is this already? Gray one is what? Steam reforming with the steam reforming is a steam reforming. The quick color is the steam reforming with the carbon capture. Then now you know already with the carbon capture. So which the carbons can be reduced from 11 kg to 0.4. Yeah, it can be reduced. Then this one is the blue color with the carbon captures. The blue color is carbon capture from 11. No, from 11 to 3 to 6. That means almost reduced more than half. With the carbon captures. So you see the long-term impact, because as I mentioned, after you store the carbon, then what to do with your carbon? Just keep storing. So for me myself, it's not really solving the problems. For me myself, not really solving the problem. Yeah. Then this one can be less. Is what turquoise is they use a pyrolysis, and we have the one pyrolysis. We can convert the 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 carbon into the solid carbons. Solid carbon, and solid carbon can be have the explore the potential applications like the carbon nanotube or carbon nanofibers. That one might be still, for me, is still feasible, because there are a lot of the fundings funding last few years provided into for this one a lot, you know. This technology, right? This one is relatively new technology. New one, because it's a better one, because the demand of hydrogen is increasing. How are you going to get the sustainable? Yes, biomass is a good, but the overall year is slow. Overall year is slow and low at this moment. So that's why two things you can do. I mean, faster develops the totally green hydrogen energy from the biomass, and also the green hydrogens. Yeah, that's the things. This one is harmful. So this one is the annual hydrogen demand. So as I mentioned just now, basically the Japan, Europeans, and US are the demand is keep increasing. So this is the opportunities that you have. Yeah. Then the policies for the energy economics. So we need to make the overall process process more cost effective. So overall process more efficiency and flexible. Flexible. The fuel cell cost if you want to make the green energies so the fuel cell cost must be lower and more efficiency and more stable. Yep. Fuel cell technology also not really stable until now, because it's already how many, almost more than 200 years. Yep. So we must have the long term makes storage, like what I mentioned just now. The overall, if you want to make the hydrogen economy, so the overall hydrogen ecosystem must be built. Ecosystem including where? Not only the productions, productions, storage, transportations, and until the utilization and go back to the production. The overall ecosystem must be built. So that's why the R&E in the material-based storage must be carried out because how to make it proper storage. Then must be have the support from the fuel cell and also the consumption. Consumption must have the support as well. This one the turbine system, pump systems. So to build the hydrogen supply and distribution infrastructure as well. So lastly, we need to create or ensure the customer or the consumers acceptance. Why? Because when we talk about the hydrogen, people worry about the safety issues. So how you going to ensure the safety issues? Safety is another challenges with which I didn't mention here. The safety of the hydrogen. So how you going to ensure the safety power to ensure the end user will be accept or your consumer will be accept. Oh, this one is lastly is what is the advantage of the proper waste management? You see, our waste management, as I mentioned, can be converted into the many type of the different technologies. The main aim here is to reduce the municipal waste, the industry waste, or even the agricultural waste to reduce the CO2 emissions from the incineration process, and also use the renewable and low cost feedstock. Can use as a renewable and low cost feedstock from the biomass waste and convert this waste into the ultra clean diesel or clean energy or clean biofuel. So we need to find a suitable sustainable method to convert this biomass waste into some useful products. So you see, by treating the waste, all these waste not only do good for the environment, but also a good business for the local and also the global economy. Because why? Because no matter you like it or not, those biomass waste, you need to go through the certain treatment, correct or not? So if your treatment techniques, can be turned this waste into some dollar and cents, and why not? So at the same time, it's become the good business plan for you and also good for the environment. So it can be kill two birds with one stone. Yep. Yeah, that's all. So any other question about that? Any questions for this one? Finish. Any questions? Which one? Pre-treatment. Which one? This one. This one. This one. Oh yeah. This one many type of the pre-treatment for example agricultural waste maybe we need to pre-treat and to select the metal. Okay, for example, you have the certain type of the what waste I want to plastic for the plastic. No, you need to make sure your feedstock or the samples are well treated. For I give you one example. Now when we help one company to go through the waste treatment conversion process for the waste tire. Before we can go through the thermochemical conversion of the waste tire, we need to what? make it small pieces because the tire content of what? Small steel, you know. And then we need to take out this all steel, or this all we call it the pre-treatment. And also the other type of the maybe the series strut, we need to make sure, for example, you need to maintain the certain moisture content. That is all the pre-treatment, so that you can have the consistent feedstock or raw materials to go through the waste conversion process. This is all the pre-treatment that we need to do so that we can have the consistent process. Sometimes, some okay. For example, plastic, you need to stretch it into the I don't know how many cm. It depends on process. Maybe to maybe less than 1 cm. Example, pieces. That is all the pre-treatment that. Or then the plastic. We have a different type of plastic. Maybe you have to categorize what type of plastic. This is all the pre-treatments. Yep. Or cleaning process or whatever. Yeah. Correct. No, no. For this one, the sources are from the fossil sources. Natural gas, from natural gas. Or if you get this source, then followed by the anaerobic digestion. No, why you want to anaerobic digestion? Correct. Okay, the biogas, you see, the biogas that is produced is already can be used, so you need to separate out the hydrogen if you want the hydrogen. Correct. Can. This one I already, this one is for me, if you ask me, as long as it go through the steam reforming with the carbon captures, it's considered brew. Brew. If go through the steam reforming, if you ask me, yeah, because the process will produce the CO and CO2. That's why. Yeah. Yes, correct. During the process, yeah, carbon production will be that's why. No, that's what is, you see, the sources from renewable energy, sunlight. Renewable energy. Yeah, that's the thing. So yes, I know. In order to get the totally green hydrogen, very difficult. Based on this definition. Yeah. Based on this definition, it's very difficult. Yes, correct. I mean, if you want to classify as a green hydrogen, yeah, it's very difficult. Especially you want to get a sustainable. Sustainable, that means what? So that the production consistent the production, because mostly the biomass convert to the hydrogen. The yield is very low, then not stable or whatever. Yeah, that's the thing. So that's why. From biomass. Okay, biomass. There are two process. What is the process? The biological process or thermochemical process? There are two process. No. Both process are different. Show you here. No. Both process are different. For the thermochemical. Okay, of course. The first thing is the raw materials. Raw material itself. Then if the go through the techniques, if the biological treatment, you need to know what is the yeast or you are using, or what is the bacteria you are using. That is one thing. And also the total, what is the total retention time, and total what is the pollutant of your biomass. That's all things. Then for the thermochemical process is also the same thing. What is the catalyst you are using? What is the temperature you are using, and so on and so forth. That's the thing. Might be affected. Then what is the total reaction times? Yep. Yes, the composition will affect. I mean, that's why the raw material will affect a lot as well. The raw material. So that's why it is recommended. That's why I mentioned recommended to do the element analysis. Element analysis. Yeah. CHN. CHN. Yeah, normally we don't want more oxygen, less oxygen. Yeah, want to have the less oxygen. Yeah, because we want a hydrocarbon only. As close as possible to the hydrocarbon is better. So oxygen might be one of the factors that produce the CO or CO2 during the process. Yep. Still another method, correct. Correct. So we don't want the oxygen for the process. Yeah. Yep. So yeah, any other? Yes. Storage. This one. Previous one, I think. This one. Challenges. This one. Truck. This one. No. Okay. This one, in order for you to transport 1500 gigajoule of the energy, the energy, if this in the form of the petrol or diesel, it's only need 2.2 truck, 2 by 2, not even half, 2 and 2. Then for the LPG, same amount of the energy, you need 3. But for the hydrogen, this one is a for the liquid hydrogens, we need 7.5. Then for the compressed hydrogen, C is compressed hydrogens at 700 bar, need 13.4. If we just compress to half of the 700 with 250, maybe we need the double. Yeah, that means you see, in order to transport the same amount of the of the energy from the hydrogen, you need 26.8 truck compared to the 2.2, which is how many times? Maybe 10 times, more than 10 times, higher. Yes. Per kilometer. Correct. You see, the calorific value will different, so they already change it into the common units.
Kilometer of distance that you travel, what is the transportation cost? Because that is essentially.
Cost. I don't have the cost. I don't have the cost.
No, but this is equivalent to cost, right? Number of trucks is equivalent to cost.
I mean, if you want to say the cost is the more than 10 times higher. 10 times higher. If we compare the cost linearly, it's 10 times. But not linear. This is non-linear. I tell you, this is non-linear. If we compare linearly, it's 10 times. Yes. This is like what you mentioned, can convert into the cost per kilometer. But if linearly, we got other costs also, right? Might be involved. If just per km, yeah, it's more than 10 times. Yeah. 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 I know. No. I know you all must go very detailed. You know, must go very detailed. So no, you know, I can answer this. You question. If we go into the detail of everything, we go to everything cannot be solved. Because in this world, work in that way. We need to take one benchmarking. For example, for those eating the vegetarian, what is the vegetarian mean? Bacteria consider the living thing or non-living thing? They cannot say that. You understand? You want to see? Yeah, we must take one benchmarking. You understand? Ah, this one do details already. If we talk about the killing the bacteria is killing or not? Living thing. If by scientific, that is a living thing. What is the living thing? As long as I can move, I can breathe, can grow, is a living thing. Yeah. we don't compare until because as we compare, we can compare with one benchmarking. So that's why do the scientific research is very important. The benchmarking, what you want to compare with. The benchmarking, your benchmarking study, your baseline study is very important. Compared to what line? I know. I know. Everything happen is also growing because the natural resources also will create the growing. But the thing is the impact of the human behavior toward this global warming is much more higher compared to the, as I say, the natural climate changing. You know, natural climate changing also will create the global warming as well. But the impact is much more less. Maybe I can say 1,000 times less than the whatever the human activities contribute to this global warming. That's the thing. Mm. Flooding is no. I can assure you, if no human in this world, flooding will be happen. Flooding is depend on what is the definition because don't know here. Some of the land is covered by the water. You consider the flooding or not? You understand what I mean? Flooding means we live here, then we have the water. We call it flooding. If no one living, you are not saying the flooding. That is the sea water increasing only. You understand? This is the definition only. You understand? For me, for me. For me, that is the definition only. Yeah, definition because we must have one benchmarking. What is the definition of the certain thing? So that's why when we do the research, that is just the terminology, you know. What is human? Human, we have this one, we call it the human, combined together, we call it human. But if we separate scientifically, this is hand, it is head, whatever, that is the thing. So we have to put the definitions. What is that? Human including the female and male. So you want to say, we only consider male or female only. So that's why we need to put the very precise definitions. If not, people will question you as well. You know, that's the same question. When you do the research, if I'm the judge, I will question you. If you didn't put the proper definition, then I'll ask you, why you didn't do this one? Yeah, that's the thing. You know, sometimes because sometimes the benchmarking and the baseline is very important to compare. So don't go to extreme. Don't go to extreme. Not necessary to go do it in this extreme. Yeah. Uh, uh, uh. Can. Correct. This is what I mean. Yeah. Yeah. Right. Correct. 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 Because this earth is has so many years. You see, it's go through many transformating because go through the IH era and many era because many disasters happen even without the human activity. But after we have the human activity, we can predict out the what the temperature increase is much more higher compared to there are no any human activities. Yeah, that's the thing. Yeah. If you change, if you cause a global warming, if you cause, because naturally it's like this, yeah, it's naturally. Yes. In European, we already have the hydropower heavy duty vehicles and also the bus. Okay, that's a very good question. Very good question. Similarly, you see our gas tank. Previously, we also worry, maybe 50 or 60 years, we also worry, but from time to time, the technology improvement, I mean the safety can be ensured. For example, another thing is just like the nuclear energy. So how you going to make sure? So from time to time, the safety factor might be improved. Yeah, that one. Yes, currently, I admit that the hydrogen is relatively not safety compared to your compressed natural gas. Yeah, yeah. But from time to time, for technology, yeah, it might be improved. Like for example, for the safety of the aeroplane also increasing from time to time due to the technology improvement. That I believe one day might be. Yeah. Okay. Any? If not, I will show you another things. The last small parts. Which this is some of our study that I didn't make the PowerPoint. Our study about the, you see, why I want to show this one we do the experiment and also the technological analysis and environmental analysis using this one. I'm not sure using the Aspen or not. Yep. Let me see first. This one we are using the Aspen Plus or without the Aspen Plus? Or someone you asking about the Aspen Plus? Yeah, this one using the Aspen Plus. You see, this is one of the very good case study that we are doing, which we combine the experiment data with the Aspen and as well as the economy and also the environmental analysis, which we are using the palm oil waste, palm oil, treat out the palm oil waste. Then with the medical protective coating, because during the time, this one is after COVID time, we found that there are a lot of the medical waste. So we do the experiments, experiment works to see what is the post-metal analysis and also the element analysis to get the primary data. For that, then we go through the co-paralysis with the medical protective coatings and also the, this one just one. I think we do three. One, two, should be three case. 2.3, where is the 2.4? 2 only. 2.2, 2.3. Yeah. This one is the oil palm waste. This one is the palm kernel. It's palm kernels. With the one to one. This one by going through the experiment study. Then after that is go through the process simulation study. So what we are doing is we go through the drying and co-pyrolysis. Then obtain get the solid products and go through the combustions. Then we propose. So our experiment we conduct from here and here. Then this one go through the combustion part is go through the simulation to see what is the potentials of the biochar. Is it can be used as a coal-fire with the coal power generation to produce the electricity generation. Then we have the bio oil. We assume we are selling the bio oil directly. Then we see the what we see is the economical analysis, and also first is the technology feasibility, then second is the economical feasibility, and also the environmental assessments. Then what we get, so for the techno-economic analysis, so this is all the assumption that we make. This is all the assumption we make, because from the previous study I didn't show you. We have this all thing for the what is the lifespan, total lifespan, then construction years, how many years, then the production preparation. This one you need to go through how many percentage of the tax depend on the certain country. So some of the input is get from the simulation directly. Then some of the costs is normally we take from the how many percent from the total production cost or total consumption cost directly. Then which including all the electricity, transportation, fixed costs, and all these costs to make it what the economical impact inputs. Then the payback period, how you going to calculate the payback period? Then all we calculate with at the present value, So that's why for the present, because we calculate 20 years, we cannot yet get the current year money. So from the life cycle assessment, this is what I want to show you. Then we start from what? We start from plantation, because from the plantation we are using the electricity, we use the fertilizer, water, diesel for some generator. So this one we need to take into the consideration, because all this will contribute to the CO2. So this is how we do the life cycle analysis. I mean, we need to set the boundary. For example, if you want to set your boundaries, you can see set the boundary during for the consumption stage only. Then you can start from the coal production of bio oil to electricity only. Then this one we start from the very beginning until the consumption, the combustion, and also until it's produced the electricity. This is how we set the boundary to do the life cycle analysis. This one. So for this life cycle analysis, we didn't use the CIMA Pro. That one we just also calculate by obtaining these all factors. For the plantation, what is the emission unit? For example, how many carbon CO2 will be produced per hectare of the land that we plan to use, because we use the pump. Yep. And also the transportation, and also what is the for the project, I mean for the overall combustion production process, including the combustion unit. So how many CO2 will be produced? So this one we just consider this all thing. Then from there we can calculate out. This product distribution is from the experiments. Then this is the potential pathway. We need to know this potential pathway. We only can do the simulation, the simulations. Then this is what the simulation gives to us. So how many for example, how many 3 types. Why over there 2 types only? Okay, 3 types of the pumps with. Then go through the drying and crushing process. So then we left how many kg. So this one, the mass flow will be obtained from the simulation, from all the process. At the same time, the energy consumption for each stage will be obtained from the simulation result. So this one we have 3 scenarios. 3 scenarios using the different types of the pumps. Then after that, then from there we can obtain the total scenario 1, 2, and 3 for the this one, the cost analysis, techno-economic analysis as well. Then what is the payback period and IRR? Then payback period is more than 6 years. So this is the sensitivity analysis. This one, this time the sensitivity analysis we do based on the payback period. You can do the payback period based on the what? The overall production cost as well. This one we based on the payback period. Because the investors want to know what is the payback period if something going on extra. So then after that, then we can see these are three scenarios. Three scenarios meaning three different type of the pump waste. So what is the total emissions can be produced? Then with the total greenhouse potential, greenhouse gas potentials. So this one, negative, that means what? Negative is the energy can be saved. Okay, you see, how we calculate the electricity output, we compare with the business and user scenario. What is the business and user scenario? We compare what is the power generation are using in Malaysia. Malaysia normally using two type of the power generation. One is a coal and another is a natural gas. So we compare with this one. So how many the CO2 can be offset if we use we use the what, the coal fire of the biochar that we produce. So how many percent can be offset? Yep. So yeah, this is what we have. So from here we can analyze in which part can be produce more emissions, from this part. Yep. That is one of study that we do from experiment, from simulation to the environmental and also the economical impact for whole studies. Yep. This is the catalytics. Just now, one of the participants asked me what is the suitable catalyst, then what is the yeah. So you see for the pyrolysis, normally we are using the AEM and also the zeolite for the pyrolysis. So this is the year that we can get. So that's why you see for the pyrolysis process, normally what we get is the bio oil and biochar. Right? For the gasifications, we will get the gas or the syngas. So this is a catalytic for the fast pyrolysis, which is using the AEM and also the zeolite. This is a typical catalyst we are using. No. As I told you, normally I use the commercial catalyst. Just use catalyst unless some of the process I want to play of the catalyst. Normally, I only use the catalyst for the jet fuel production because that one is very important. Because if not, I cannot get the jet selectivity. That one I cannot get. But for the pyrolysis or whatever, even without the catalyst, we also can get our bio oil or whatever. I think, correct or not? They are not so crucial. My catalyst, normally my catalyst team is designed for me to produce my jet fuel. Because jet fuel is very important. The selectivity is very precise. Must be carbon less than C16. So that's why they need to push toward that what to call that reactions. But for this one, we are not so crucial about that unless I want to design the certain what to call certain biochar to become the carbon nanotube. That one we might need to design a certain catalyst on that carbon nanotube or carbon nanofiber. That one have to design the catalyst. If not, the normal biochar not necessary. Normal biochar. Yeah. So this is the, then we have two types of the catalyst, homogeneous catalyst or heterogeneous catalyst. So this one we list out accurately. What type of catalyst and what is their effect? You can go to refer. What type of catalyst with what is the feedstock? So what is the effects? Then we list out clearly. Then we have the heterogeneous catalyst. So this one is a gasification. The gasification. This is the catalyst that we are using from the study. Yep. So Normally for the gasification, the hydrogen and also the CO are the gas that we obtain. Obtain. Of course, sometimes the CO2 will be produced. So that's why. No, you can download because IIT I found that IIT is have IIT. So if you want, you can download now here. No, but yes, uh, most of available. I only found a few are not available. Because I stay in the guest house. I also access the internet in the guest house. Most of it I think I can download, but only few. Yes, believe only very less. I think most of the journal in the site I like can be downloaded from IIT database. But this one definitely can because I download from here. Only one paper I cannot download. This paper. This one, the green hydrogen. This one, maybe the latest one cannot or whatever. This one. This one we do a study about this one. Only this one we cannot. I cannot download. But all this one you see I download from here. IIT. Can if you want. I can send you now. Which one you I can send you. I can access. Yeah. All papers. Okay, no problem. This one this all paper lah. Then I download that related to these courses. Can I can share. No problem. WhatsApp group. Can this all papers. Yeah, I can share with you. No problem. That one. So this one we do on the green hydrogen. So we categorize with what is the hydrogen energies. So what is the benefit and drawback of the hydrogen? So what is the chemical properties? If we know the chemical properties, so we can design what is the storage medium for it. That's why. Yeah, no. Hydrogen production technology. This one is I just quickly go through only. These applications already covered. So yeah, for the from what we can know is if from the renewable sources is more green from our definitions because we don't have one definite definitions. So more green process is biomass process can be go through the biologicals or the biophoto catalyst, dark fermentation or photo fermentation, thermochemicals. Yep. Very low, less than 10. Less than 10. Oh, thermochemical, I mean from what sources? Biomass. Biomass also quite low, I can tell you. Around 10 to 15, quite low. 10 to 15. Char, and also other gas. Other gas, char and other gas. So yeah, that is the process. That one is also just now back to a question. Thermochemicals based on back to a question whether you heat it at high temperature or low temperatures. It's different. If the relatively lower temperature, oil will be produced as well. Liquid product, not oil. Aqueous product. Yep. I mean the is pyrolysis. So yeah. So from the fossil fuel, this is all the techniques that I think I already covered with you. Different. This one is more details. What I this one I already covered. Water splittings have yeah, renewable sources. So this is a fuel cell technology. Fuel cell technology, I not go into the details because we are not in a fuel cell, but just for information, there are many types of fuel cell, but the working principles is almost similar. Just some of the fuel cell is working for the high temperature, lower temperature, or the medium temperatures. So some they can use the methanol as the fuel. Some cannot. Some must be use the pure hydrogen. Some can be used the what to call methanol. Methanol. If you use the methanol, the CO2 will be produced. This is what. So any other, this one is we list out the green hydrogen production method by using different electrolysis methods. So they are the pro and con. So some of you keep asking me, what is the best method? Best method. Best method, I mean, what is your definition of the best method? Your definition, cost effective or less negative environmental impact, or what is that, or higher char or high quality of the char. This one you have to put the definition. What is the, so there are no any so-called best, so there are pro and con for each process. Yeah, depend on the target. What is the target that you want to achieve? Yep, I think that's all I want to share. So any questions, any comments? This one to produce the biochar, the pathway to produce the biochar. So any questions? So if not, I think that's all. We end our course today. So later on, I think we will have what?
So, thank you, Professor Ong, for insightful session from Monday till today. So we have completed the lecture session with this last lecture session by Professor Ong. Hope we have covered all the scheduled lectures that is shared among you. Right. So if you have any doubt, we'll discuss. Just we have 10 minutes before lunch. And after lunch, we'll again assemble here. We'll have a short exam as we have intimated you. So we'll get a QR code scanner here, which you can scan and attempt from your mobile also for the exam. And post that, we will have again feedback form is shared with you. You can fill in the feedback form and return back to us. And after completing the exam, you will be given the certificates. So we'll have lunch. Post lunch, we'll assemble here again for the examination and your certificates.
From 6 to 11. Feedback form. There is a break. So is it 8 feedback from the those dates? Is it from 6 to 11?
So in the feedback form, the course date, you just fill it 6 to 11.